If you were to think of a vehicle that was like the vehicle that won the Second World War, what would you think deserves that title? Some tank, a bomber, an aircraft carrier? All valid candidates, sure, but today I'll talk about another one, the workhorse of amphibious landings, the small but essential Higgins Landing Craft. I'm Indy Neidell. Welcome to a World War II special episode about the Higgins Amphibious Landing Craft. For the American military planners, the possibilities of getting involved in a war in the Far East rapidly increased after Imperial Japan's advance into China in the late 1930s. However, such a campaign across the Pacific would involve fighting on the many beaches of numerous contested islands and shores. The U.S. Marine Corps, whose primary job it would be to storm those beaches, advocated for the incorporation of a specialized landing craft into their arsenal. The U.S. Navy fleet landing exercises in 1937 demonstrated the need for something beyond the simple ability to deliver troops to the shore. Speed and efficiency were key when it came to unloading troops and their equipment, as well as the boat's ability to quickly retire from the beach to make room for reinforcements. So far, they had been practicing with motor launches provided by the Navy, which were known as bureau boats, but these were really not up to the job. With several technical problems and design flaws, the Marines were too exposed to gunfire, or were hindered in disembarking from narrow bows. Propellers were easily damaged by debris, or the keel buried itself deeply into the beach. All in all, the Marine Corps was not thrilled with the Navy's efforts, and an actual feud between the two branches broke out over who had control over amphibious operations. The major spokesman of the Marines was Lieutenant Victor Krulak. Krulak had been a military observer of the war in China and brought back first-hand knowledge of how the Japanese soldiers were unloaded at the beaches by the Daihatsu landing craft. The Daihatsu was a solid boat, able to carry a load of 10 tons at a speed of 8 knots. It was 47 feet long, and although it was constructed out of welded steel, its 80 horsepower kerosene engine was strong enough to propel it from the shore without external assistance. Krulak put in his reports that if the U.S. Navy wanted to be competitive, they needed a landing craft like this. For this, he approached Andrew Higgins. The boat building company Higgins Industries was already a household name in New Orleans by the late 1930s. Higgins had begun specializing in building small but versatile boats that could easily traverse the shallow waters of Louisiana's swamps and bayous. The local trappers and oil companies needed a workboat that could repeatedly run aground on the shore, offload, and then back off again without damaging the hull or the propeller in the process. Nicknamed the Wonder Boat, Higgins' Eureka was a big seller. The Eureka was designed with a wide bow profile, whose rounded shape reduced hull friction and in turn increased its overall speed. The reinforced forebody was robust enough to withstand repeated beachings, and the propeller was protected inside a tunnel from floating debris. Its rounded bow shape also expelled the aerated water to the side, which prevented the propeller tunnel from becoming clogged. Quite an ingenious design. Both the U.S. Army Corps of Engineers and the Coast Guard were already customers of Higgins, and when approached by the Marine Corps through Krulak, Andrew Higgins was convinced that his Eureka boat would prove ideal and be far superior to the proposed bureau boats of the Navy. He traveled to Washington to meet with the convoy and routing section. The Navy laid out the specifications for the boat they were looking for. It needed to be at least 30 feet long, with a weight of 10,000 pounds, and be able to carry a load of 5,000 pounds. With enough room to transport 18 men and a stationary machine gun, the boat needed to still move at a speed of 10 knots. The Eureka was improved to satisfy those demands. Higgins also modified the stern to better deflect waves to the sides and added a small rudder to the front of the propeller to assist retracting from the beach. After a few months in the workshop, the new Eureka was ready. In 1940, it was chosen as the designated landing craft for the U.S. Navy and Marines. By that time, France had fallen to the Germans, and British High Command saw itself facing an occupied continent. Sooner or later, large-scale amphibious landings would have to take place on the shores of Europe. So far, the British had been using their own designs, most commonly the Assault Landing Craft, ALC, made by Thornycroft. It was a sturdy boat with a low silhouette and silent engines. They were used in the campaign in Norway and at Dunkirk with great success, and were prepared for commando operations against the Japanese in Burma. The Royal Navy expressed interest in the Eureka, though, which was 5 knots faster than their own landing craft. But they asked Higgins to produce a longer version than 36 feet. The reason for this was that British boats used long gangplanks deployed over the bow, so the troops could exit straight ahead instead of just climbing over the sides. Once more back to the drawing board. Higgins modified his boat again. The result was astonishing. Not only could the longer boat carry twice the number of troops, but it also handled better at sea, which led to a higher speed with the same engine. They also added self-sealing fuel tanks, 2 forward machine gun pits, and additional protection for the crew. By October 1940, the U.S. Navy had approved the new design as well, and the Eureka officially went into mass production. The new Landing Craft Personnel, LCP, or just Higgins Boat, became the new standard. With the help of contracted manufacturers, hundreds of boats were built over the coming months. The Eureka had combined its own particular design with features of the Daihatsu. See, the only thing still kinda missing was a landing ramp. The men still had to jump over the sides of the Eureka to disembark, which not only took time, but also unnecessarily exposed the men. Krulak's reports had mentioned Daihatsu being outfitted with a large bow ramp, through which the Japanese troops exited at the front. Yet Higgins was hesitant about changing the Eureka's design too much. Several prototypes had failed to produce satisfying results. The ramp made the boat too heavy at the front, which jeopardized its retractability from the shore. The solution lay in rebalancing the entire boat by relocating the engine to the center. By 1941, Higgins had made a prototype that worked, which became the Landing Craft Personnel Ramp, LCPR. The new ramp was just 3 feet 4 inches wide, but it made landings significantly easier. And it did not end there. Over the war, the Eureka would further evolve into the Landing Craft Vehicle Personnel, LCVP, and the Landing Craft Personnel Nested, LCPN. But for the time being, both the American LCPR and the British ALC proved to be the best solutions to an operational problem. LCPRs were usually stowed in ship superstructures or carried by specialized auxiliary personnel attack ships. Once inside the embarkation area, the crafts were lowered into the water with only their crew on board. The men had to descend via the nets from the hull of the ship, which could be pretty difficult on the high seas. Then, in preparation for the assault, the LCPRs would be guided by control boats to the assembly area. The control boats were usually also Higgins boats that had been modified with communications and radar equipment. It was their task to gather the formation or to quickly break it off in case of a sudden air attack. The formation, presenting a wave or a line, was also flanked by modified LCPs carrying rocket launchers, heavy weapons, or smoke screens. Once everything was gathered at the rendezvous point, the assault would begin. At first, the landing craft would advance at 3/4 speed, while the support boats sped ahead, expending their ammunition against the designated beachhead. Then the command would be given to accelerate to top speed and prepare to disembark at the shore. Of course, it was not perfect. Nothing in war is ever perfect. Designing a landing craft meant finding a compromise between the qualities that made a good seagoing boat and those of one designed to be beached at the shore. To avoid a bottleneck, the men at the rear would still have to jump over the sides and could find themselves neck deep in the water. The limited side armor forced the men to hunker down to escape enemy fire, and until they were offloaded at the shore, the tightly packed group was a real target for the defenders' guns. But the new landing craft really was a game changer. Now, amphibious landings were not only more feasible, but could be done rapidly and to the best possible advantage for the troops involved. More than 23,000 of Higgins landing crafts would be manufactured during the war and were used in pretty much all American amphibious operations. It is often crowned the most innovative landing craft in naval history, and its contributions should not be underestimated. Post-war, President Dwight Eisenhower would state, Andrew Higgins is the man who won the war for us. If Higgins had not designed and built those LCVPs, we never could have landed over an open beach. The whole strategy of the war would have been different. And Colonel Joseph Alexander of the Marine Corps would add, the Higgins boats broke the gridlock on the ship-to-shore movement. It is impossible to overstate the tactical advantages this craft gave U.S. amphibious commanders in World War II. So, let's at least add the Higgins boats to the conversation of war-winning machines, right up there with the big flashy things like aircraft carriers and heavy bombers. We did a 10-part, minute-by-minute, 5-hour series on the attack on Pearl Harbor in collaboration with World of Warships. It was awesome. And episode 1 is right here. And so we can do more cool stuff like that, which no one has done before. Join the Time Ghost Army at timeghost.tv or patreon.com so we can continue to transport these special episodes to you. See what I did there, Astrid? Because it's about transport? Yeah? All right. See you next time.